Hello everybody, in this lesson I will discuss a difficult exam question where we use the sine rule. In the diagram, AC represents a vertical tower. Point A is the top of the tower and point D is a point on the tower situated h meters below A. The angle of depression from A and D to point B in the same horizontal plane as C have magnitudes x and y, respectively. The distance in meters between points B and C is B. Question 1. Express B1 in terms of x and y. So when we go to B1, we can see that B1 plus B2 is equal to x, and your reason is they form alternate angles, and can you see it's the two of them together, that's x. But B2 is equal to y, and the reason is alternate angles. Therefore, we can say that B1 plus y is equal to x, and therefore B1 in terms of x and y is x minus y. The second question, express A1 in terms of x. So when we go to A1, can you see that there is a right angle there? Because that's the horizontal and the angle. Therefore, A1 is equal to 90 degrees minus x. And then we're going to use the information in this slide in order to work out the next one. Now the question says, hence prove that P is equal to all of that. Now remember, in the previous slide, we said that B1 is equal to x minus y. And my advice to you is fill it in on your sketch. And A1 is equal to 90 degrees minus x. There, I filled it in. Now let's see. Again, we want P. So where do we start? We go to the triangle furthest from P, which will be the non-right angle triangle ADB, and we will make DB the subject of the formula. There. So we start in triangle ADB. That's the non-right angle triangle. Let's make DB the subject of the formula, where we will use the sine rule, and it's DB over sin A1 is equal to AD over sin B1. Why did I use AD? Because that one contains the H. Then DB over sin A1 is 90 degrees minus x is equal to AD is H over sin B1 is x minus y. We calculated it in the previous slide. Now we find this sin 90 degrees plus x, 90 degrees minus x. Do you agree that's a reduction formula and a cofunction? So that thing reduces to cos x. And now we can find dB. We make dB the subject of the formula by multiplying with cos x both sides. Now we have dB, the link between the two triangles. dB's length is h times cos x over sin x minus y. Now we move to the other triangle, DCB, and we want P. So that one is a right angle triangle, and it's normal sin, cos, and tan. And the one that's going to work is cos of B2 is CB over DC. Since CB, cos's ratio is adjacent over hypotenuse. Then we can make CB the subject of the formula by multiplying away the dB both sides. Then from the previous sum we know dB's length, and we substitute dB's length, the one that was, it's this one, h times cos x over sin x minus y times the cos y, and we write it on top. Therefore, we have proven that. In the next lesson, I will discuss the formal proof of the area rule. Click on the video in the left-hand corner to take you straight to the next lesson.